Hi students, this is Kumar, your maths teacher, grade 8. So next third method is by long division method. For larger numbers, we use the long division method for finding their square roots. So this requires to pre-estimation of numbers of digits in the square root. So now let us see a few examples of long division method. So the first question is find the square root of 529. Find the square root of 529. So the first step, so the question is 529. So the first step, bars for every two digits starting from right to left. Bars for every two digits starting from right to left. So here one bar, here one pair. So 29. So 5 is a left. So the next, this is the first step. So the second step is, so here 5 is a left. So 5. So 5, finding the nearest perfect square. So 5. Find the nearest perfect square. We know the perfect square is 1, 1, 1 is 1, 4, 2 2s are 4, 3 3s are 9. So here is 5. So 2 2s are 4. 2 2s are 4 right here. So finding the nearest perfect square. So the next 5 minus 4. 5 minus 4 is 1. So next bring down the next pair. 29. So the next step is multiply the 2 by the quotient. So the quotient is 2 multiplied by 2. 2 2s are 4. 2 2s are 4. So here 129. 129. So here is 4. So we know that the ones place of the square number is 9. So here the ones place is 9. So ones place of the square roots is 3 or 7 will come, correct? Ones place of the square number is 9. Ones place of the square root is 3 or 7 will come. So now you substitute any one number. So first you write 3 is here. So this number also you write here. So now you multiply 3 into 43. So 3 into 43. So 3 3s are 9. 4 3s are 12. So now, so 129. So now subtract 0. So therefore the square root of 529 is equal to 23 is the answer. So the next example is find the square root of 17.64. Find the square root of 17.64 by long division method. So the first step, we know that first step, make a pairs from left to right. Make a pairs of left to right. This is the first pair. So next, so the first pair is 17. So 17, find the nearest perfect square. So this 17 perfect square is 1 1 is 1, 2 2s are 4, 3 3s are 9, then 4 4s are 16. So here is 17. So the next perfect square is 25. So this is here 17. So write 4 4s are nearest perfect square is 17. So less than 17. So 4 4s are 16. So next you subtract 17 minus 16. 7 minus 6 is 1. So next bring down the pair. So here decimal, so 4. So the next, the quotient is 4, then multiplied by 2. So 4 2s are 8. 4 2s are 8. So next here 164. 164. So here the unit place is 4. Here the unit place is 4. We know that ones place of the square number is 4. So the ones place of square root is 2 or 8. Now you substitute any one number. Now substitute any one number. Now I substitute 2. 2, then 2 also here you substitute. So now we multiply 2 into 82. So 2 into 82. 2 2s are 4. 8 2s are 16. So the remainder is exactly 0. So therefore square root of 17.64 is equal to 4.2. So the next one is, if the perfect square is of n digits, then its square root will have n by 2 digits. If n is even, n plus 1 divided by 2 digits. If n is odd. If a square if a perfect square is of n digits, then its square root will have n by 2 digits if n is even, n plus 1 by 2 digits if n is odd. For example, square root of 4096 will have 2 digits. Will have 2 digits. So here 1, 2, 3, 4 digits. So 4 digit is even. So even, so n divided by 2. So 4 divided by 2. So 4 divided by 2 is 2. So we'll have 2 digits. So the next square root of 25,600. So here 5 digits. So 5 is odd. 5 is odd. So n plus 1 divided by 2. So 5 plus 1 divided by 2 is equal to 6 by 2. 6 by 2 is equal to 3. So we'll have 3 digits. So square root of 25,600 is 160. So here the square root of 4096 is equal to 64.